So we've got a question here. What we want to do is solve for x. Sine of 2x plus cosine 2x equals pi. Now I've got the line here on the graph, which is y equals pi. And here I've got the graph of sine of 2x plus cosine 2x, which has a frequency of pi over 2. Now we can see here that the maximum point on this graph is root 2 and the minimum is minus root 2. Now at no stage does this graph ever touch the line y equals pi. So as this graph here is continuous and will follow this frequency all the way along here and all the way along here, there is no real solutions. So what we have to do is we have to step over to complex numbers and see if we can find a solution there. So let's let our x equal z. So z is our complex number, where z equals a plus bi, and I is our imaginary constant, which is square root of minus 1. So let's transfer this over into our z units to start with. So sine of 2z plus cosine of 2z equals pi. Okay, now what we need now is to find the exponential identity for sine and cosine. Now we know that sine of z equals e to the I z minus e to the minus I z all over 2i, and cosine has a very similar look. Cosine of z equals e to the I z plus e to the minus I z, this time over 2. So what we can do is we can plug in 2z into these exponential identities and put them in here and set it equal to pi. So let's do that. So sine of 2z. So first of all we'll have e to the I 2z minus e to the minus I 2z all over 2i. That's our sine. Now for cosine, e to the I 2z plus e to the minus I 2z, this time over 2, and then set that equal to pi. So in complex analysis, these are equivalent equations. Okay, now let's deal with denominators. So let's see if we can get a z out of this somehow. This looks like it's an impossible task at the moment, but let's see what happens. So if we multiply every term by 2i, we can get rid of these denominators. So 2i multiplied by everything inside these equations. So these ones will cancel out, we'll just be left with the numerator. So we've got e to the I 2z minus e to the minus I 2z. That takes care of this one. And then this one, cancel out the 2, but we'll need an I to be added into our numerator. So we'll add I times e to the I 2z plus e to the minus I 2z. That takes care of that. And then we must multiply this pi by 2i. So I'm going to write that as 2 pi I. Okay. Now I've got e to the I 2z, e to the minus I 2z, all the way along on these 4 terms here. Now what I do know is if I multiply a positive exponent with our exponential multiplied by a negative version, the resulting answer is 1. So for example, e to the I 2z times e to the minus I 2z, if I multiply those together I just get 1. So let's multiply everything by the positive version. So e to the I 2z times by everything in this equation. Okay, times this with this, that's going to give us e to the I 4z. So e to the I 4z, and then multiply that by that, I just get 1, but then I've got a minus sign here, so I've got minus 1. And then same here, I've got I, which is a constant, to be multiplied by the exponential. I've got e to the I 2z times e to the I 2z. that's going to give me e to the I 4z. Okay, so I've got plus I e to the I 4z. Okay, now I've got here e to the I 2z times this one is going to give me 1, but I've got an I here as well, so I'm going to have a positive I in its place. And then here I've got e to the I 2z times 2 pi I. Well, 2 pi I will be the constant in front of the exponential, so I'll write that as equals e to the I 2z times pi I. So 2 pi I times that. So times 2 pi I. Okay, now what we got here. So I've got e to the I 4z. Now I could rewrite that as e to the I 2z and then square it. Then I've got all e to the I 2z's again as I had to start with. So let's do that. So now I've got e to the I 2z squared. So that's going to give us the same as that. The minus 1 can stay. This one I'm going to write with the I in front with this term as well next to it. So plus I, and then open bracket, e to the I 2z, and then squared. I as well, I'll just add I again. And then this time I'm going to bring my 2 pi I in front of my exponential. That equals 2 pi I e to the I 2z. Okay, I'm being careful to make sure my 2's don't look like my z's, because that's an easy mistake, and then all of a sudden you end up with more z's than you originally wanted. Okay, so I've got squared and squared of e to the I 2z, so I can maybe factor these ones out with the I in here. I've got possibly a 1 here as well, and I've got a minus 1 plus an I. So I'm going to rewrite this as 1, that to multiply that one, and then add I, and then e to the I 2z squared. So that's that term there and that term there taken care of here, and then minus 1 plus I. And then what I can do is now I've got another e to the I 2z which I can bring over this side. So I've now got minus 2 pi I e to the I 2z. So that's the same as what that is. So I'm just going to put that in a bracket like that one. So then I've got e to the I 2z, e to the I 2z, this side, this one squared, and set it equal to 0. Okay, so now what I've got something that's a little bit like a quadratic. So if I set another variable to be t equals e to the I 2z, let's do that. T equals e to the I 2z. And then we'll write this in quadratic form in terms of t. So I've got 1 plus I times t squared. So that's the t squared. Then I'm going to bring this one ahead of this one to leave the constant on the right hand side of this side of the equation. So then I've got minus 2 pi I and then just t. And then I've got minus 1 plus I, and then set that to 0. Okay, so now I'm ready to now work in terms of quadratics. So now what I can do is I can put these into the quadratic formula. So this one here will be my A. This minus 2 pi I would be my B. And minus 1 plus I, that will be my C in terms of the quadratic formula. Okay, so now let's take this off the board, make a bit of space, and let's see if we can solve the quadratic formula in terms of these constants. Okay. Okay, so now ready to solve for t in terms of the quadratic formula, which is written on the side here. So as with all quadratic formulas, there's two solutions with a plus or minus. So let's go ahead with this one. So t equals minus b, which is minus 2 pi I. So I'm going to write that down like that so we can see what's going on. And I've got square root b squared minus 2 pi I squared, and then minus 4 times a, which is 1 plus I, and times c, which is minus 1 plus I. Okay. Now, to find our solutions for this quadratic formula, we need to be at the top of our game in terms of complex analysis. So now I've got 2 times 1 plus I. So there's plenty of little tricks along the way here to get us to our answer. Okay, so minus times minus 2 pi I, that's straightforward. So now we've got 2 pi I. That's okay. Still plus or minus. Let's see what's going on in our radical. So 2 pi I squared, let's be careful here. So minus 2 squared is 4. Pi squared, pi is a constant, it's not a variable. So we've got pi squared. And then we've got I squared. Well, if I equals square root of minus 1, I squared is this one squared. So therefore that's going to give us minus 1. So then we can now put a minus sign in the front of this minus 4 pi squared. And now we've got 1 plus I times minus 1 plus I. Let's go careful with that one. 1 plus I minus 1 plus I. 1 times minus 1, minus 1. I times minus 1 is minus I. So that's this one taken care of. Now let's distribute with this positive I on this side. So now we've got to add I. And then here we've got I times I, which is I squared, which is minus 1. So therefore this cancels out and I've got minus 2. So therefore I've got 4 pi squared times minus 4 times minus 2. So I'm just going to leave it like that for the moment. You'll see why on my next line. And then my denominator, I'm still going to leave as 2 times 1 plus I. Because it looks like I could be able to get a 2 out of this with a 4 here and a 4 here. So if I could factor out a minus 4, so let's try that. 2 pi I plus or minus square root. Now let's just take minus 4 out of both. And then I've got pi squared. Take the minus 4 out of that and factor it with that, and I've just got minus 2. So therefore I've got minus 4 times minus 2, minus 4 times pi squared, as I got there in my radical. Now I can do something nice with the algebra. So now I'll just divide all that by 2 times 1 plus I. Okay, let's have a look what we've got here. So basically what I've got here, if I just write this up on the side, I've got the square root of minus 4. Remember all our rules with surds. I can do minus square root of minus 4 and then square root of pi squared minus 2. This is equivalent to this. This is the same thing. Now minus square root of 4, I can rewrite that as 2i, and then this will just come down. So now I can rewrite this with a 2i and take that out of this radical here. So now I've got 2 pi I plus or minus my 2i. So I've got 2i and a 2i. I've got a 2i here, but this one's with a 1, so that's just spoiling the party a little bit. And then I've got square root of pi squared minus 2. And then 2 times 1 plus I. Okay. Now what I'm going to do first, I can cancel these 2's out. So let's go for that. So now I've got t equals pi I plus or minus I. So don't forget that I still stays there. Pi squared minus 2. So this, inside this radical now, this is going to be a real number. Pi squared is around about 10, roughly. Minus 2, so it's going to be around about 8. So square root of something around about 8 That's going to give us a real number. And then we divide that by 1 plus I. Okay, right. Now we've got this in terms of t, but my question wants me to give my answer in terms of z and then x. So we need to do something in terms of this. So let's take this off the board and let's try and get this in terms of z. Okay, so here we are. We've got this all in terms of t, and that's how far we've got so far. So we've come quite a long way here. Now we've got t equals this. T is not what our goal is to find. Our goal is to find z and then x. So t is in this form. So this t here, I can write that as e to the I 2z, and then that's equivalent to t. So that's what I could write now as my equation. So I need to get z on its own out of this. So to do that, if I take the log, natural log on both sides, I can cancel the e. So let's just write this inside here like this. So natural log of e to the I 2z. So that takes care of that, equals this. I also need to take the log of this one. Now here I've got my absolute value because I don't know if the whole of this is going to be a positive number or not. And with my imaginary constants in there, I'm going to need these. Okay, so log of e, I to the 2z, that's going to give me 2iz. So I'm going to write it in that format with a constant in front of my variable. And that equals the natural log of pi I plus or minus square root pi squared minus 2 over, let's put that in a bracket. So that's nice and tidy in there. So that's where we're up to so far. And now what I need to do to get z, I just need to divide both sides by 2i. So let's do that. So z equals, now I just can't put the 2i inside the log, it still has to stay outside or underneath the whole thing. So I'm just going to write 1 over 2i as a constant on the right hand side, and then multiply that by the natural log, absolute value. Now, I just missed out an I in there, let's put that I back in. Was concentrating putting that I in. So natural log of pi I plus or minus I square root pi squared minus 2, and that's all over 1 plus I. Okay, so I can rewrite my two solutions, one underneath with a minus sign. I'll leave this one with a negative positive sign here. So that's one solution. So z1 equals that, and z2 equals 1 over 2i natural log pi I minus I square root pi squared minus 2 over 1 plus I. They are my two solutions for my z in terms of complex analysis for the answer to my equation at the beginning. Sine of 2z plus cosine 2z equals pi, transferred from real numbers into imaginary numbers. And these are my two solutions. So if you want me to solve these completely by taking the natural log of these, leave a message in the comments below, and I'll show you how to find the natural log of these two solutions in terms of complex numbers in the form of z equals a plus bi. So I'll turn them into real parts and imaginary parts. Okay, so that is going to be my final answer for now, and then I'll solve these another day if you leave a comment. Okay, thank you.